For this question, we want to use the graph of y equals 2 to the x and transformations to sketch the exponential function 2 to the x minus 5. We want to determine the domain and range, and also determine the y-intercept and find the equation of the horizontal asymptote. So we're going to start by sketching the graph of 2 to the x. We're going to do that by plotting points. I'm going to use a standard set of points that I typically start with. That's -2, -1, 0, 1, and 2. We'll substitute these into the equation y equals 2 to the x. And I'm going to start with the easy ones first. So let's start down here with an x value of 1. 2 to the first power would be 2. 2 to the second power would be 4. 2 to the 0 power is 1. Any number to the 0 power is 1 except for 0. We have 2 to the -1 power. When we have a negative in the exponent, we are going to do the reciprocal of the base. So to apply the negative, we need to have the reciprocal of the base. And then we'll still raise it to the first power, and that gives us 1/2. And we have 2 to the -2 power. The negative, we do the reciprocal of the base, and then raise the power to get 1/4. So that gives us a set of ordered pairs, and I'm going to graph this equation. We've got the ordered pair -2 1/4, -1 1/2, 0, 1, 1, 2, and 2, 4. So this is the sketch of our graph, our base graph, 2 to the x. And this function will get closer and closer to the x-axis without ever reaching it. We have a horizontal asymptote that is right on top of that x-axis. It's the equation y equals 0. And what we want to do is we want to use this basic function to graph this function here, f of x equals 2 to the x minus 5. So our function is f of x equals 2 to the x minus 5, and we want to use transformations to draw that graph. So what I notice is that I have one transformation, which is this -5. Because we are subtracting, this is going to be a shift. And that subtraction is in the exponent, and that makes it inside of the base function. And when an adding and subtracting is inside, that makes it a horizontal shift. Then we have a minus, so that means it's going to shift to the right. And we're subtracting 5, so we're going to shift right 5. So that means that all of the ordered pairs that I found on the graph of y equals 2 to the x will shift right to be on the graph of 2 to the x minus 5. So let's use a different color. How about this purple here? And I'm going to move each point to the right 5. So this point that is 2, 4, if I move that to the right 5, we will be at 7, 4. We have this point 1, 2, which will move to the right 5, and it'll be at 6, 2. 0, 1 will move to 5, 1. negative 1.5 will move to 4.5, and this point, negative 2.25 will move to positive 3.25. So this graph that has been shifted to the right 5 units is right here. F of x equals 2 to the x minus 5. And as I said before, the graph in black is y equals 2 to the x. And one of the things that you may need is those ordered pairs. So those ordered pairs on the new graph have shifted right 5, and you'll notice that the y values have stayed the same and only the x values have changed. So I'm going to extend my chart here, and I'm going to write down the ordered pairs that are on x, f of x. So on the original graph, we have the ordered pair negative 2.25. If we shift to the right 5, I am adding 5 to the x-coordinate, and that moved to 3.25. This ordered pair, negative 1.5, so we've already done this using the picture. I'm just using the ordered pair now. If we shift to the right 5, it's only affecting the x-coordinate. So I'm going to add 5 to the x-coordinate to get 4.5. The next point, 0, 1, we're going to shift that right 5. Right 5 only affects the x-coordinate, so I'm going to add 5 to the x-coordinate to get 5, 1. And then the next one is 1, 2. We're going to shift right 5 to become 6, 2. We have the point 2, 4. If we shift right 5, that will become 7, 4. So I want to make one more clarification before we answer the other parts of this problem. These ordered pairs in this column here are on the graph of f of x, and the ordered pairs that you see here are on the graph of the basic function 2 to the x. Okay, so let's continue. We want to make sure we find the domain and range. The domain of every exponential function is all real numbers from negative infinity to infinity. We can confirm that with our ruler. If we start on the left, this arrow here indicates that the graph continues on forever, so our domain starts at negative infinity. This arrow here means that the graph continues on to the right forever, and so our domain goes from negative infinity to infinity. Then we can hold our ruler horizontally to find the range, and you can see that on the bottom here, there are no y values until we get to this horizontal asymptote at 0. So the range will start at 0 and will continue on to infinity. We have a range that starts at 0 and goes to infinity. We also want to determine the y-intercept and also the horizontal asymptote. So our original horizontal asymptote was at y equals 0, and you can see that because we didn't shift up or down, that horizontal asymptote didn't move. So the new horizontal asymptote will also be y equals 0. So finally, let's determine the y-intercept. You find a y-intercept by letting x equal 0. So in my function, I'll substitute a 0 to get 2 to the 0 minus 5. That's 2 to the negative fifth power, which is 1 over 32. So the y-intercept is 0 and 1/32. I think we've met all the parts there. Thank you for checking out my videos. Have a great day.